Hey, well, hello, everyone. Greetings. I am Nick Edwards, the Vice President of Product Management at Menlo Security, and I'm joined by Mike Ryder, our systems engineer focused on the federal market. Today, we're going to talk about Menlo Security's approach to zero trust, using a different way of thinking about it, and that is through the power of isolation. And that's something that Menlo has pioneered and has had a lot of successful deployments around the world for customers who are interested in improving their security, realizing that the existing approaches have shortcomings. So today we're going to talk about our philosophy towards this, how it works, how it impacts customer environments to improve the security, and then we'll kind of close with a demo of the capabilities in use. So for starters, a little bit about Menlo and our approach in the federal market. Menlo was selected a few years ago to protect the entire DoD from security threats on the web using isolation technology in a kind of a zero trust model. And obviously to do this, we have to go through a high level of scrutiny to meet the very stringent requirements by the DoD. And a lot of that has compliance implications. Obviously, we're very engaged with the FedRAMP model. We're in process in FedRAMP. And overall, our approach is really targeted and ideally suited for customers around the world who have these types of highly sophisticated security requirements and are also very targeted by cyber criminals and nation states and threat actors around the world. So this means that we have a variety of Global 2000 customers, large financial institutions, as well as large government agencies outside of the US, such as in Singapore, Japan, and other countries around the world. And this is all powered by our cloud security platform, which is built from the ground up. It's cloud native that offers the comprehensive secure gateway technology to embed isolation into the user's browsing practices and policy framework on behalf of our customers. To scale appropriately, that means you have to have a cloud that is multi-tenant and elastic. It needs to be highly available. It needs to be rapidly deployed to solve customer onboarding requirements. And ultimately, it has to deliver. And that means it has to eliminate threats. And that is where kind of our approach to isolation really delivers value for customers. And as we talk about zero trust, it's worth remembering that zero trust is about flipping the model of trust on its head. Instead of the old days where you could essentially extend trust very generously, and once someone passes a single point in time confirmation of who they are, you could give them the entire keys to the kingdom. Well, zero trust flips that on its head, and it says you'll have to verify trust explicitly as often as needed based off of the business requirements, and it's based off of the users, where they are, who they are, what they're trying to access. And isolation is a critical part of this. And CISA, CISA, which is the Homeland Defense Department's agency for cybersecurity and infrastructure, has kind of promulgated isolation as a strategic architectural approach to enhance security. And it provides a wide range of benefits. Clearly, first of all, it isolates potentially malicious code content. And the value here is eliminating ransomware attacks while not impacting the user's ability to do their job. And it allows users to click on any website to perform their function, whatever it may be. And it reduces the need to have complicated, highly maintenance-heavy allow listing and blacklisting that we all know cyber criminals have an easy way to get around. And also it doesn't require a ton of user training, because the intent of isolation, if done right, is it is completely transparent and native, and it doesn't break the browser experience for the users. It also gives administrators the ability to set tunable policies. We have customers who isolate all the web traffic going to the internet, and we have some customers who kind of isolate varying degrees of web policies and kind of websites. It all depends on the policies that are needed by the customer, by the agency. But ultimately, there are certain core elements that have to be delivered. It's not just about isolating kind of the browsing experience. It's also about being able to isolate every download, attachment, link, and click that a user may interact with, as well as on not only on a desktop, PC, et cetera, but also on a mobile device, smartphone, or tablet. And one of the main value benefits here is it diminishes the attack surface area. I think with Menlo, we'll talk a little bit further about this. Isolation is just not a kind of a toy that can be applied for very limited use cases. It is baked into everything that we do. It is baked into not only web traffic scanning, but also to how we apply CASB policies, DLP policies, private access policies. If done right, it can be applied to every attack surface that customers have when they're accessing applications on the internet. And this is one of the key capabilities and benefits that the agencies have identified as part of the strategic architectural foundation that is driving the adoption in the Department of Defense and other organizations around the world. It also provides a rich source of insider threat intelligence within the browser. This is really interesting and compelling. When you think about the evolution of cybersecurity tools, in many ways it mirrors kind of what our users are doing around the world. If you rewind the clock 20 years ago, when the internet was not as robust, we didn't have SaaS applications, we didn't have Dropbox, we didn't have O365, everything was inside the network for the most part. And everyone did the work that they needed to do their job pretty much on their machine, on the machine that they were working on. So the endpoint had all of the applications, it had all the data, it had everything that the user did. So the industry responded to the fact that cyber criminals were trying to attack this endpoint. And so we have rich source of AV and a variety of other analysis tools, forensic tools focused on the endpoint. But what's changed? Well, what's changed is all the work now happens in the browser. When you think about your day-to-day job, what are the applications that you might use locally on your machine? Well, you might use an Excel spreadsheet or some spreadsheet of choice. You might use some of the kind of tools that might be available for more complex software development technologies that are available on the endpoint. But a lot of users, the vast majority of the users that we see and the customers that we talk to are using all the SaaS applications that allow them to be agile and to accelerate their business objectives or organizational objectives. Salesforce lives in the cloud, all the file sharing services live in the cloud, increasingly O365 and kind of email and collaboration tools live in the cloud. And all that leverages the web browser. And so what that means is the web browser is the primary target of cyber criminals. And a lot of the threat intel tools, a lot of the forensic tools haven't quite caught up to that reality. And so to try to get rich threat intelligence, you have to try to triangulate with a lot of different log sources, SIM data and a variety of other capabilities. Well, one of the benefits of browser isolation is you can use isolation to get all that telemetry to provide for this richer set of threat intelligence. And that's one of the things that the capacity enhancement guide has articulated. And then, kind of very important and not to be forgotten is the command and control links are also disrupted by using isolation, and it neutralizes some existing malware that might already be in the network. And then kind of lastly and critically important is isolation, when done right, does not increase the browser's memory usage. It does not slow down the user experience. It does not create friction or any cognitive overhead for the users. There's a wide range of sophistication when people are using the web. Some are more experienced, some are less experienced. But one of the things that is totally and completely fundamental is that all users will complain if the browser experience is slow, if they're trying to download a file, they're trying to do something, and it looks like the security tool is breaking their ability to do that successfully. Browser isolation has to be transparent to the user. It has to deliver value in a way that's secure without costing and compromising the overall efficiency of the organization. And when done right, isolation delivers that. I think that's one of the main drivers that the system enhancement guide is really trying to articulate here. And that's why, again, it's been adopted by a lot of large and sophisticated organizations around the world. And that was why the Menlo was selected for the DoD CBII initiative, which is the kind of the cloud-based internet isolation project. This was a very highly visible project over the past several years. Dozens and dozens of vendors were kind of competing for this business. And they were trying to solve some of the challenges that the DoD was wrestling with, which was quite fundamentally imperfect security. Web browser being a large threat vector, other capabilities that were being explored or in use had an impact to web latency and impacted the web experience of users. And just as lot of you probably realize the increasing costs associated with maintaining on-premises security were being compounded by a variety of factors with just distributed teams, distributed organizations and units around the world. And also the fact that to deliver security in this model required backhauling traffic to a centralized location to access the web, and that introduced a wide range of bandwidth challenges, backhaul costs, and so forth. So Menlo's securities approach was to deliver an effective, scalable, and secure model to do this that would improve the agility while not compromising security. And so we were able to deliver this with our CBII win. We allow customers in the DoD, a wide range of agencies, to have improved web experience. It reduces cost by kind of eliminating the need for a variety of legacy proxy functionality that might be on-prem. And it gives this comprehensive visibility, such as inspecting SSL traffic, providing DLP integration to protect sensitive data. And it creates kind of this virtual air gap to keep malware off user devices. I mean, I think a lot of us are familiar with this model of, kind of a device that can access the internet, which is separate from the device that can access kind of the local network. And this was traditionally known as kind of the air gap, SIPRnet, NIPRnet, these sorts of things. Well, CBII allows these critical employees of our government and our Defense Department to not have to make that type of kind of physical leap. It can be integrated into the product in this mode that delivers this virtual air gap that provides for a comprehensive set of policies to enable the organizations to do their job without compromising security. And by mere fact that they're going through kind of a platform like this, it routes non-mission traffic through the cloud platform that delivers some really compelling and interesting bandwidth limiting controls to reduce the bandwidth costs for the organizations who are using it. And when they did this, they bought the entire Menlo Security stack, including our isolation technology, including our cloud secure gateway that combines data loss prevention and CASB to improve not only their threat prevention, but also enhance data security capabilities as well. And the benefits here were pretty stark within the first 90 days. And we talk a lot about the security aspects, but it's really important to realize that you don't get the security until people are on the platform. And to get people on the platform, that means you have to scale quickly and substantially. And in the first 90 days, we had over 150,000 users on the product. And this had a dramatic improvement in three main vectors. One is the number of file downloads dropped by 70% because you can render these files in isolation. Mike will show you more of how this works during the demo shortly. But with file downloads being one of the primary threat vectors for getting ransomware and other bad payloads on the network, just by being able to eliminate the number of downloads will result in a dramatic security posture increase immediately. The same thing goes with malicious websites being visited. We'll have more data on that shortly. And ultimately, the VPN bandwidth dropped substantially. Over 100 terabytes of VPN bandwidth were offloaded in the first 90 days. And now that we have well over 1 million of users on this platform, for DISA and mission partners around the world, these statistics have gone up and improved kind of security posture significantly. And this is kind of one of the proof points of how Menlo can support the NIST cybersecurity framework. If you look at kind of the NIST 853 guidelines, then kind of where this intersects zero trust, there are a variety of functionalities that are supported to address these core principles of, identify, protect, detect, respond, and recover. And that means that when you're thinking about zero trust, when you're thinking about isolation, it has to be baked into the entire platform in a thoughtful manner. I think there are a lot of different approaches out there that stem from acquired technologies that kind of are bolt-on functionality onto the vendor solution to try to address zero trust in a way with isolation. But that typically doesn't embrace the wider range of security capabilities that are becoming table stakes, kind of in the market, such as data loss prevention, such as the CASB functionality of the cloud access security broker, as well as things like private access and firewalls as a service. All of these capabilities, if done well, can leverage isolation to deliver on the promise of zero trust and to help conform to these NIST guidelines. And when we think about it through the lens of the zero trust maturity model, when we look at these pillars, there's a lot of areas where isolation and our approach deliver value. We talked about data and DLP and using data security to do that. The mere fact that there's a lot of file tools that when you upload them end up kind of chunking up the data. There's a lot of ways to bypass DLP scanners just via the nature of web traffic. Well, going through an isolation layer provides for a comprehensive, centralized view to have the visibility that might typically be lost for data loss prevention. And that's a key area that Menlo's approach to isolation can help deliver. There's a variety of capabilities on the network side associated with scanning fully encrypted traffic, integrating with APIs. We discussed CASBs, as well as the application proxy that is very relevant and very compelling. The application and workload is also a very strong component of zero trust, where Menlo is able to deliver value with not only kind of the approved prohibited list of applications, but also really providing kind of the visibility and access for kind of anytime, anywhere, and quite frankly, any device trying to access the applications or workloads that are required. And then kind of wrapping up here with visibility and analytics, we're able to provide for advanced threat protection using kind of our product natively, as well as with some of our forensic tools, as well as being able to work with monitoring and auditing platforms that have the requirement for using our data to have visibility into the users and what they're doing to help comply with any of the audit requirements they may have. And where appropriate, we'll partner with different technologies to deliver areas here that might not be our core focus, such as SIM, which will allow us to integrate with the wide range of SIMs out there with our standard interfaces to SIM data to Splunk or other types of SIMs that might exist in the market, or with our kind of go-to-market partners. And then lastly, with automation orchestration, the data that we have with capabilities such as our browser forensics tools that allow customers to extract data from the browser can really help shorten the time to incident response, so customers and agencies and mission partners around the world can shorten the cycle to respond and to help improve the security posture while an incident may be underway. And these are all becoming more and more relevant because the threat landscape, unfortunately, shows no signs of slowing. And in fact, during the pandemic, it increased dramatically with folks working from home and really leveraging the mind share that COVID-19 had in terms of phishing attacks, ransomware attacks, et cetera. I think from 19 to 20, we saw double-digit increase in the number of phishing attacks on a percentage basis. Ransomware appeared and continues to appear in breaches around the world. This is also compounded by the prevalence of cryptocurrencies as a vehicle to extract the ransom. And I think very importantly and very critically, malware still originates overwhelmingly via kind of the web and email, with phishing and overall kind of downloads and so forth, corresponding to 90% of the origination of malware. And these are all capabilities that a zero trust approach powered by isolation can help address. And so kind of one of the ways to think about it from an architectural perspective is that means that you need to have a way to provide coverage for users wherever they are and whatever device they're coming from, whether that's managed or unmanaged devices, whether that's kind of remote employees or people in the regional or main offices. And one of the best ways to deliver that is via a cloud platform to help minimize the overhead and costs. And when Menlo delivers this value, basically we're able to eliminate the threats via our cloud platform. So what ends up getting delivered to users on the browser is essentially a clean, sanitized browsing experience that is powered by Menlo. And so they're protected from malware, phishing, and these malicious documents. And the way we do this is probably best understood through contrasting traditional approaches to detection. So when you think about kind of the legacy approaches, it's all around patient zero, where customers need to identify the threat first and then have rules deployed against that. And when you think about that from a browser perspective, when a user goes to a website, in a traditional model, the fetching of that content, the executing of that content, and the running of that content happens on the end user's browser. And so if there's for example, a browser exploit that may exist out there, well, all that's going to get through, and then this access to the internet that may be risky is going to manifest, and the user may be compromised by that website. Well, with Menlo, what happens is that kind of application that may be kind of fetched and executed, all that's going to occur on the Menlo platform itself. So what ends up getting relayed to that endpoint is just rendered content that is rendered not by the original website that may have malicious payloads or may have exploits, et cetera, but it's rendered by Menlo. So Menlo is essentially painting the pixels on that end user's device. But it's not just kind of legacy VDI technology. It is purpose-built for security using the latest and most contemporary software development techniques and leveraging what the cloud has to offer. And so we do this with our own kind of remote browsing protocols. So when the user interacts with that website, they're not interacting with it directly, they're interacting with Menlo. And we're able to do things like put the files into isolation if they're viewing it. If the user is coming in from a mobile device, well, they're not actually going to that website on their mobile device, they're actually going through the Menlo platform. And so this access to the internet is isolated, and Menlo is stripping out the active content, providing security controls, and making sure that anything that may be malicious doesn't reach the endpoint. It's providing this buffer, as we alluded to earlier, this kind of virtual air gap, so the content that gets rendered is safe, secure, and not going to infect those users. And one of the things that we are seeing that is really driving adoption is an increase in highly evasive advanced threats. We refer to this as heat. And these are kind of a family of threats that are using really innovative techniques to evade security defenses that exist in the market. When you think about the tools that exist in the market today, they've been around a while. A web proxy has been around for decades. And a lot of the cloud secured gateway vendors are using legacy architectures just on a different form factor. When we've thought about delivering security, it's not about just, hey, let's port this on-prem appliance to the cloud. It's about how can we use the cloud differently to deliver enhanced value to provide for better security. And this is how we're able to protect customers from these types of attacks. So I'll go through some of these in detail here, and I'll give you a couple of examples in the subsequent slides. I think the first common thread associated with a heat attack is kind of using dynamic file downloads. And they do this by evading the legacy secure gateway content inspection via techniques such as HTML smuggling. Another common attack is kind of evading link detection engines on the email path by social media sites, via SMS, via files and shared file services that might contain a link that would normally be an email phish that is actually in the file that someone's accessing via kind of a third-party file sharing site. Another common evasion technique is evading categorization and other IOC-based threat detection techniques. And they do this by using kind of ephemeral links and sites. It's easy to spin up a link that happens thousands of times a day all around the world. And these links are not going to be categorized as anything yet because there's not a lot of history on it. And unfortunately, we can't block every unknown website because that means that you're going to start to impact business and you're going to get IT help desk tickets that are soaring. And so how do you address this notion of ephemeral links or other compromised sites that have kind of a benign categorization? And then lastly, a lot of these techniques evade some of the traditional kit detection methodologies for phishing or JavaScript or visual detection because the content is dynamically generated on the browser, or it might be also obfuscated content as it goes through. So the signature matching techniques associated with proxies and malware scanners or other sandboxing techniques aren't going to be able to detect it because the content is actually executed on the browsers, which are only becoming more and more powerful. And that is how some of the cyber criminals are bypassing the evasion stack. And when you look at kind of the traditional security stack, it's probably not too different from this for a lot of the customers in the world. You have a secure gateway that may be on-prem or maybe in the cloud. You have a variety of antivirus, sandbox phishing techniques, URL scanning, and so forth. And you also have a variety of firewalls, IPS systems, et cetera. And if you were to kind of do a Google search on ransomware attacks and other kind of breaches, all of those customers had some version of this. They probably had a lot more of this in their network, but they were still being impacted. And that's because this content is zipping right through that and leveraging the power of the browser to execute the code to deliver the malicious payload, whatever it may be. And that is basically kind of the heat attack synopsis at its core. This content is constructed at the browser after it gets through the security defenses, and the endpoint technologies really aren't designed to really identify what's happening on the browser. So let's just give a kind of a deeper example here. So, this notion of HTML smuggling is a good case where dynamic file downloads evade kind of the antivirus and sandbox policies. They basically use this technique that hides the ultimate payload in this dynamically constructed manner using the HTML and JavaScript, typically using kind of a blob base64 DOM object. And it does not require a separate HTTP request, and it doesn't include a file that can be scanned. So that means that the HTTP request that ultimately would kind of traditionally create the file doesn't happen because it's executing code on the browser. And the network security devices can't actually scan the file because there is no file. The file is created dynamically on the browser on that endpoint. And so it evades all those techniques that might traditionally have caught these things in the past. And ultimately, Menlo, with our Threat Labs team, we've discovered a lot of this capability via some of our different research and kind of Threat Labs, kind of investigations. Some recent ones that we've discovered are Isomorph and Operation RIG that are using these HTML smuggling techniques, as well as Jury. So I definitely encourage you to kind of look these up on the web. You can find out more about these in further detail. And similarly, Microsoft is also starting to kind of report on these as a very common threat vector, particularly associated with some of the most recent ransomware attacks over the past year. Another technique that I kind of referred to is the targeted spear phishing that evades email. I don't know about a lot of the viewers on this webinar, but I receive a ton of SMS messages that have links associated with, hey, your cell phone bill has been paid, click here for your prize, or maybe shipping notifications that I never ordered, a variety of things that would try to dupe me into clicking this link on my smartphone. Now, if you have a traditional secure web gateway, it may not actually be seeing this traffic because it's coming in directly to the phone via an SMS. Well, with Menlo, we can actually use isolation to protect that mobile browser on the smartphone, on the tablet, to deliver security from these types of attacks. And that's just one example. A variety of other social media devices, kind of job sites, et cetera, also include these as a particular technique to try to dupe the users into clicking on a link and then being, kind of harvested. And then, kind of another big area is, as I alluded to, this notion of domains evading web categorization and IOC detections. These malicious websites can be created so easily, so quickly, and they can be thrown away at very low cost. And when they're created, that means that these web categorization technologies need to look at that site, analyze them, and provide some notion of a classification. And typically, a lot of the links and the websites used in these, supply chains of ransomware attacks and other threats are not categorized because they're not necessarily associated with, any business. They're just sitting out there. It might be used, months from now, and so they don't have any negative history. And so it bypasses some of the traditional kind of categorization technologies out there. And another technique might be compromising kind of not very popular, not very well protected sites that are classified as good. So all these things will bypass some of these technologies. And ultimately, we've seen a dramatic growth in this over the past couple of years, over a 280% growth from kind of the 2019 to 2021 timeframe. And these are basically these websites which are considered good, but actually they're bad. And it might bypass some of the traditional filtering because you don't have this technology in place to provide security. And we continue to analyze this, and when we think that the threat feeds are just going to be too late to provide security on a regular basis, with hundreds of malware domains being created monthly, thousands of new phishing domains. Now, all these are problematic, and by our math, conservatively, at least 10% of these malicious domains are identified too late, kind of after patient zero has basically been infected. And the way that we can deliver this is by using isolation. But to make that possible, first of all, you have to be able to scale dramatically. And with our architecture, we deliver that via this elastic edge that scales kind of vertically and horizontally to give the capability and the compute for customers wherever they are. So it scales horizontally by being able to onboard thousands, hundreds of thousands of customers very quickly. But also it can scale vertically to deliver the bandwidth needed, the CPU needed, as well as the storage needed to provide for the right level of security, depending upon where the user is and what they're trying to accomplish. And this elastic edge is what allows us to power our isolation technologies that can then be applied in a variety of capabilities. So we look at the isolation technology as not just a single point feature, but this broad set of tools that can then be applied for different use cases. So we have things such as kind of read-only web. So imagine a use case where you want to make sure that websites that may be unknown, yet they may have business value. So you want to put them in a certain category where users can actually view them, but not necessarily interact with them. And so we have this technology approach called read-only, which would allow users to do that. And that is powered by our isolation core. We talked earlier about some of the forensic capabilities. Well, that's where Browsing Recorder comes in, where we record the user sessions. We store that in customers' environments so the customers can have that data available for them. And then they can use that to help quickly respond to incidents and other issues that may be happening in their environment. And there's a variety of other capabilities here in this isolation core that ultimately power our zero trust private access products, secure gateway, DLP, CASB, and so on. And so it's not just a point solution that is used for one niche use case. Isolation can be applied for a lot of different technologies to deliver on the promise of zero trust. And I'll give you a very specific example with CASB. CASB is a technology that allows for doing a lot of different things to understand what's happening to SaaS traffic in your network. Companies typically will say, hey, first of all, let me see what our users are doing. And then they'll get a list of all the different shadow IT that's being used. Then companies will apply policies for sanctioned SaaS apps and unsanctioned SaaS apps. And then they can apply more liberal and generous access controls for sanction, and then maybe block or do something else for the unsanctioned. Well, with Menlo, what we'll do is a lot of customers will apply isolation for files coming from unsanctioned SaaS apps. So let's say you have policies that say, I want to allow our users to access Dropbox because that's sanctioned, but I want to make sure my users can do things like they need to apply for a mortgage or upload or download files for other personal reasons during the business day. Well, I don't want to break their ability to do that. They might find a workaround anyway. So what customers will do is they will apply isolation for documents and files for unsanctioned apps. So that way, anything that's going to kind of a non-corporate platform can stay in isolation and they can maintain security without causing a lot of headache and friction for the users. And this is done by a purpose-built platform that provides for global coverage and can integrate with customer environments, integrate with customers' existing tools, and ultimately help improve their existing investments in other security operations center technologies. So as we kind of get ready to approach the demo, it's just worth noting that probably a lot of people have heard about SASE as a model and kind of these new frameworks and new approaches to delivering security for organizations. Well, our perspective at Menlo is isolation is a key tenet to deliver on SASE and zero trust, and it provides for security kind of across the board, not only just with email, but also web, not only just web access controls, but threat prevention, And then when beyond threat prevention, kind of the data protection associated with kind of DLP, CASB, and a variety of other capabilities. And our perspective is we have the technology. It's a function of how does a customer want to consume it. You know, we can be your primary secure web gateway. We can kind of integrate with your existing tools. It's really a question of the customer roadmap, where they are on their arc towards transforming the network to embrace more of these zero trust principles and more of these frameworks that might exist in the network. So with that, I'll kind of pause and I'll hand it over to Mike to kind of walk through it in deeper detail, this approach to zero trust in action and how customers can leverage this technology to improve their security posture without introducing friction, without changing the web experience for the users, and to hopefully help accelerate their ability to do their mission more safely and securely. So Mike, I'll hand it over to you.
All right, thanks, Nick. If you want to advance one slide and then I'll take over. Sorry about that. All right, so good morning, everyone. As mentioned earlier, my name is Mike Ryder and I am a federal systems engineer with Menlo Security. So for the demonstration portion of our presentation, I'm going to be focusing specifically on scenario 2 across use cases 1, 2, and 3 as seen here on the screen. I'm going to be specifically providing you all with an overview and demonstration of our web isolation solution and the capabilities to meet and exceed the stated requirements. So what I'd like to do first is run through a side-by-side comparison of a user's browsing experience when browsing the web directly versus through isolation. Along the way, I'm going to be highlighting some fundamentals relative to Menlo's web isolation platform, highlighting key benefits as well as unique differentiators of our web isolation technology, and of course, highlighting how we're able to meet the stated requirements. So with that, let me go ahead and take over here, Nick, and share my screen. If you want to stop sharing for me, and then I can take over. Awesome. And here we go. So at this time, can you see 2 browsers? Just confirm that before I proceed.
Yes.
All right, awesome. So on the screen here, you see 2 browsers. On the left-hand side is my Google Chrome browser. And we'll just say that this is a user that is going direct to the internet. And maybe in the context of a government employee, perhaps they're behind some sort of legacy URL filter, or legacy web proxy. For the demonstration, it really doesn't matter too much here. On the right-hand side is my Firefox browser. This browser is going through isolation. So in the context of scenario 2, let's say that user is on their GFE, navigating the web through isolation via Firefox browser. Now, a couple of things I want to point out here real quick is, I've hit msn.com. I believe most people are probably familiar with msn.com. On the surface, this is a pretty busy site. There's a lot of moving parts here. There's a lot of content. From a user experience perspective, out of the gate, the look and feel is identical. Obviously, some of the content is rearranged differently, but that's kind of what you'd expect out of msn.com. Now, if I look underneath the hood here and take a look at the source code, not only is msn.com a complicated site on the surface, but the source code makes it even more complex, right? There's definitely a lot of code, a lot of script. If I scroll all the way down to the bottom real quick, there's literally 6,400 lines of code. So this is a really complex site. Considering that the average website, has between 1,000 to 3,000 lines of code, this site is definitely more complex on that spectrum. And of course, and as Nick has mentioned throughout the presentation, if any one of these elements is compromised or infected or contains some sort of smuggling script or encoded blob, that user ultimately is going to be infected and at risk of exposing themselves to malware. And this even applies to those agencies that have some sort of legacy URL filter or web proxy in place. All of this content is ultimately going to be delivered to the end user. Unless that proxy or filter is outright blocking the content, that user is getting that original content. So in the context of zero trust, that's completely contrary. That content is trusted completely from the time the user sends that request to the time they retrieve it. That content is trusted the entire way. Now let's take a look at the source code when going through isolation. So immediately you'll see, as I like to say, the page is much more clean and concise. There's less than 48 lines of code, but what's really relevant here and important is this source script. So through isolation, we're no longer interacting with msn.com. I'm interacting with a thin client that's out in our isolated platform. Within that thin client is a surrogate browser that's actually performing the fetch and execution of msn.com and then delivering to me a mirrored copy. So Nick walked through this process through a couple slides previously, but let me talk to it through the browser now that I have it open. So in the context of scenario 2, I'm that government employee on my GFE. I want to browse the web. So I'm going to get on my device and I'm going to open up the browser of my choice. Open up the browser of my choice. And I want to emphasize that because with our isolation platform, we don't require you to use a specific browser, a unique browser. We don't require you to manipulate or customize the browser in order for it to function properly. So right out of the gate, from a user experience perspective, it's going to be identical to if I were browsing the web from my personal device at home. Now, obviously, in most government installations, you're probably going to be segmented or required to use Edge, Chrome, and maybe Firefox. So in my Firefox browser, I'm going to execute my request to msn.com. My request is then being routed to the isolation platform. It knows to do this because there's a pack file that is referenced within the network settings of the browser itself. Again, that's not some sort of custom configuration. That's just leveraging the organic network settings that are available in all browsers. And this is precisely how the DoD predominantly has deployed Menlo isolation. So my request is received and intercepted by our isolation platform, where the surrogate browser out in the cloud is then essentially becoming that victim. That surrogate browser is fetching all of this content, all this code, executing it, and then delivering to me via a trusted JavaScript, a safe, sanitized version, or effectively a mirrored copy of msn.com, where it's rendered within my local browser. So effectively, every single time I browse the web through isolation, I'm going to be protected 100% of the time from any sort of malicious content. Because again, that surrogate browser, that thin client out in the cloud, that component is the one doing all the fetch and execution of the content, isolating it away, creating that virtual air gap, and then delivering a mirrored copy of that to the end user. So in the context of scenario 2, cases 1, 2, and 3, that user is going to be protected from end to end, no matter where they're browsing to through isolation, as well as no matter what location they're browsing the web from. Now, a couple other things I want to point out here. You'll notice that between the two, there's a large difference between the amount of content that has to be retrieved and rendered. So on the left-hand side, 6,500 lines of code, and all of that has to be fetched and executed by that local browser. And not only that, in addition to all those lines of code, your average website makes 20, 30, 40 additional calls out to other destinations to bring in additional content. So that is a lot of overhead, particularly when you scale that up to enterprise size environments. Take the DoD, for instance. That creates a ton of bandwidth congestion. It creates bottlenecks at these internet access points, and that results in a poor user experience. Well, through isolation, since we're just pulling down effectively this single script to render a web page, that results in reduced bandwidth, but also improved performance. And this has been publicly acknowledged by DoD officials on many occasions, that web performance has improved by a factor of 2 and 3 times faster in some cases. And on a personal note, I can personally attest to this. Outside of Menlo, I'm a Navy officer. I've been working in cyber and electronic warfare for nearly my entire 21-year career so far. In my first exposure to Menlo, I immediately realized that there was something different about this solution. My performance, my browsing experience was better. And then of course, being a member of cybersecurity, trying to poke holes into this capability, we quickly realized that the security efficacy was top notch. So in terms of a security product that can deliver better user experience, but also fully protect users from malicious content, that's really hard to come by. Generally, you're having to sacrifice something in order to gain security. So again, tying this back to scenario 2 and use cases 1, 2, and 3, but use case 3 specifically, where that user is operating out of a bandwidth restricted environment, this is going to improve that user's experience. This has also been proven in those DoD environments where users are operating out of high latency, low bandwidth environments. One other element I want to point out from a functionality standpoint before I get into some more focused demonstrations is the fact that you notice we have 4 tabs open here. I could theoretically open up 20, 30 additional tabs and I would have no impact from a browsing perspective. So we're not limited. We don't limit your ability to open tabs, and I call that out as another unique differentiator of our platform. So from a user experience perspective, it's going to be identical to if you were freely browsing the web from home. So what I'd like to do next is walk through one of those HTML smuggling scenarios that Nick so eloquently described. And I've teed this scenario up in a couple ways. Both of them are going to be delivered through some sort of phishing email, which is generally how that type of website is delivered, although a user could mistakenly navigate to that site and then be exposed. So this first scenario, I simply have received a link to a sports media site, and I like sports, so why not click on it? You'll notice right away when I hit this website that a file was automatically downloaded within my browser. I didn't do anything to cause that to happen, it just occurred. Let's take a look at the source code and see why that occurred. So as Nick mentioned, this is so highly evasive because to a perimeter device or even an EDR tool, it looks like benign JavaScript or HTML5 code. And we notice right here in the middle, this blob of base64 encoded text that is able to get past those devices. And then only when that browser executes the content does that malicious payload become compiled. And in this particular case, .exe was effectively compiled. And then as you click on that, I could potentially be having a bad day on my local endpoint as well as for my enterprise environment. Another scenario here, it's going to involve a similar scenario. In this particular case, we're getting close to tax season, so why not get some insider knowledge into taxes, right? So, I'm interested. I'm going to click on this link. Just like last time, a file is automatically downloaded within my browser. I did nothing to cause that to happen. Let's take a look at the source code here and just see what's going on behind the scenes. And just like last time, we see this large blob of script that's encoded that again is not executed until it gets past all those devices and the data is compiled. Now, aside from the inability of legacy tools to prevent this type of attack from occurring, think about this in the context of your typical user. I go to this website, a file is automatically downloaded. So what am I going to think? I'm probably going to think it's either a coincidence and safely go on about my day. I'm certainly not going to call the help desk and report it, right? Because they're going to ask questions. Maybe I'm going to a website that I'm not supposed to be going to. So just think about that in the context of a user. So not only is it getting past your defenses, but from a user perspective, more than likely, they're not going to report that type of activity either. Now let's run through these scenarios through isolation. Again, starting off with the sports media site. You'll notice right away that the site loads, but immediately we detect that there is a payload that's trying to be executed or compiled here. And we are able to detect that through isolation because again, we have that surrogate browser that's out in our cloud platform that's executing all of the content that's required to make up that site and even that malicious payload. So in this particular case, we detected that executable. And of course, for demonstration purposes, I'm not using live malware, so I do have the ability to download that file. But along the way, along the process here to download this file, it also goes through a series of security checks, multiple AV checks, reputation hash checks, as well as detonation and a cloud sandbox before we apply the appropriate disposition, which of course, in this case, the file is safe to download since it's just a demonstration. Had it been malicious, we of course would have blocked it. Now let's run through that second scenario involving the PDF that was compiled. Just like last time, the site's going to load. The isolation platform is effectively going to intercept that payload being compiled and then render it into this safe file viewer. So Nick briefly mentioned this on that slide, if you call, where there's a 70% reduction in file downloads. And this is precisely why. So whenever someone opens up a document, particularly in the context of the DoD, we've observed that they're simply viewing the file or that document within this safe file viewer. So this rendering here is that mirrored copy or that safe sanitized version of a PDF or a doc, for example. From here, I do have the ability to download the original if it passes all those checks and if policy dictates that I can do so. And of course, every single time I will have the ability to download a safe copy of this document. In addition to that multi-layer checks that's performed against documents, we also, when we intercept a document file or PDF, etc., we actually convert it to HTML5. And that enables us to extract all of the embedded content, malicious or good, including URLs, and provide you with this safe rendering here. So in the context of the DoD, users have been simply viewing the file here and then closing out their tab, resulting in a reduction of 70, and I've seen reports up to 90% reduction of file downloads. So not only does that reduce bandwidth, but it also reduces the potential for any security risk should, for whatever reason, this PDF or file bypass all of the security measures in place, and if that user decides to download the original file. So tying this back to scenario 2 across those use cases, isolation protects users from the most advanced threats like HTML smuggling. We also provide document protection, and we can even reduce the amount of downloads that users are taking based on what we've seen within the DoD. So what I'd like to do next is just real quick touch on browser exploits. I went real quick to the National Vulnerability Database hosted by NIST. This gives me a listing of all the recent vulnerabilities for the Edge browser in particular. I just did a search in the last 3 months. There's been 45 entries. And of course, browser exploits are a very severe thing, particularly when they're in the form of some sort of zero-day. And many of these exploits require or are started out by some sort of specially crafted HTML website or code that, when executed, results in that attacker gaining access to that exploit or that vulnerability. Web isolation protects against these types of threats as well, because again, that original content, that corrupted HTML, is never going to reach that end user. This has also been publicly acknowledged by the DoD as another benefit of isolation, protecting against those zero-day threats. Now, one thing I want to add here is generally when I bring up this point in conversations, one of the immediate responses is, well, we're just going to patch that browser. And that's absolutely what you should do. You should patch that browser. But based on my experience at a previous company working with patch teams within the US government, I found that it wasn't uncommon for an organization to be behind on patching 3, 4 weeks, sometimes as worse as 5 to 6 months. So while that is a valid approach and something that should be considered, it's not going to protect you on day 0 or day 1 or even potentially day 21, et cetera. So having isolation is going to provide you with that protection that's needed from end to end. So what I'd like to do next, before I jump into the console for a few minutes, is just run through a couple additional examples that really touches on the power of isolation when it comes to, as I'd like to say, gray area websites. So I'm gonna go ahead and expand out my browser since I no longer need that other browser for now. And I'm just gonna go to an uncategorized site. So for those of you that are not familiar with uncategorized sites, it's a site that really doesn't have a home in the context of web categories. You think about ESPN.com, that of course is absolutely a sports website pretty much every single day of the week, right? But there are some websites that don't have a home. It could be because the content just doesn't fit. It could be because it's a new domain, there's no reputation history, et cetera. But no matter what the reasoning is, uncategorized sites is something that a lot of organizations struggle with dealing with. And that's because legacy tooling only affords them one of two options: to either allow or block. Of course, there are pros and cons with each, but how about having the ability to safely allow your users to access those sites, protecting them, but then further restricting their ability to interact? So you notice on the bottom right here that a little tab is sticking out here, indicating that the site is read-only restricted. So based on policy I have for uncategorized sites, as well as many other categories, I'm going to further restrict access to that site. So effectively, I'm taking away the ability to interact with this website. So I don't have the ability to enter credentials. I wouldn't have the ability to upload data, things like that. So not only does this protect me from this type of site from a malicious content perspective, but it also provides further protection against credential theft and potentially even data loss. Now, what I really like to do is really broaden the scope of this topic. So uncategorized is just sort of scratching the surface, but think about other sites that fall into that gray area that are essential for your personnel to access. This could be personal email, it could be social media, it could be other gray area sites that are typically blocked. You know, one example I think of is a security team member that needs to access a malicious website or a hacking website. Generally, those sites are going to be blocked, and that user is going to be prevented from accessing that site, which could impact their productivity. I personally can think about times where I'm on duty, or even when I was forward deployed, where I needed to access social media for target open source intelligence correlation. And in order to do that, I had to leave my workstation, go to a kiosk that wasn't conveniently located in order to access sites that were blocked at the time per DoD policy, and then try to remember everything I just researched, go back to my desktop and continue with my mission. So definitely not efficient. On the other hand, there's also what I call a morale issue here. Within the DoD, it's called morale browsing, but think of it as leisurely browsing. You know, employees, it's human nature to want to spend a couple minutes here and there throughout the day going to sites that provide entertainment value. And unfortunately, a lot of times that's restricted due to security concerns. Within the DoD, that's no longer the case anymore. They safely allow users to navigate to personal email, to social media, to streaming media, because isolation protects those users every step of the way. So again, in the context of scenario 2, across those use cases, we're providing that end-to-end protection, no matter where that user navigates to, and potentially improving their workplace efficiency and productivity by allowing them to access sites that could potentially or would normally be blocked. Now, one last scenario I want to run through real quick before I spend just a couple minutes in the console. And this is going to touch on 2 other facets within web isolation. One of those is going to be CASB, and the other is going to be DLP. So I've logged into my Box account, and under the platform or umbrella of isolation, we also have Cloud Access Security Broker that allows organizations to apply granular policies towards a variety of applications. It could be Facebook, YouTube, or in this case, Box. So I have a policy in place that tells my users that they're not going to be able to download any files from their official Workbox account. So you'll notice I went to go download the file, and then immediately it's blocked based on policy. So that's just one example of CASB in play here. The other example I want to highlight is highlighting our DLP capabilities through CASB, but also this applies to web isolation. And this is going to apply for data going in as well as data going out of the organization. So in this particular case, I have a document with a project code word named Hercules Dynamite. I'm going to attempt to upload it, and you notice that it's blocked based on our DLP policy. So with DLP, not only are we looking at data going out, which of course is very important, but we also can inspect data coming in. And a lot of times organizations sort of forget about that aspect. You know, you think about WikiLeaks, those classified documents that are technically still classified, but are out in the public arena. Bringing that into a government environment, of course, is going to introduce spillage. So having the ability to look at data going out and in is critically important. All right, so next I'm just going to spend just a couple minutes inside the admin console just to give you all a quick preview of what the admin console looks like. Bear with me one sec while I log back in. And once you log into the console, so in the context of an administrator or operator, you're presented with a dashboard view of some of the most relevant statistics or logs from your environment. By default, we're looking at the last week, but I do have the ability to drop this down and tailor the time frame to my needs. You'll notice all these charts here. There are pie charts, bar charts, etc., indicating the top threat types, top users, categories, etc. The great thing about all of these is that they're interactive, so I can simply click on any piece of these graphs and then begin drilling down as a part of my investigation. You notice along the top here, there's more focused areas that just categorizes things in a more focused fashion. You notice we also have statistics around email. So one thing I didn't demonstrate today was our email isolation capability that provides similar protection for web for things like URLs and documents and file attachments. Moving on to the far right here, you notice this checkerboard icon. This is essentially your menu of items. This allows you to pivot within the console itself. So currently I'm on the dashboard. If I wanted to perform investigations, look at reports, user activity, I could go to our Insights dashboard, and that provides me the ability to run all sorts of queries, create custom queries or leverage pre-existing queries, create reports, etc., and then have the ability to download the reports or send those to appropriate recipients. But what I'd like to do is actually just jump into our web policy dashboard real quick, walk through some of these items, and then wrap up the demonstration as well as our presentation. So first and foremost, I land on our threats category page. So threats is actually one of our categories, but we break it out from the grander catalog of categories. And I think there's a good reason why behind that. I've worked at other vendors where threats was kind of embedded within the larger catalog of other web categories, and that can oftentimes lead to human error, overlooking categories. So we provide a focused area of threats in all the subcategories. So each of these, you notice there's a differing policy dispositions based on the administrator of the platform. So for uncategorized sites that I've demonstrated already, we have it set for isolate read only. You also see allow, isolate, and then of course we can block sites completely. I mentioned earlier, and when it comes to web browsing, whenever a user browses a web through isolation, they're going to be fully protected. You notice there's no limitation to the types of categories that a user is protected against. So that's also a unique differentiator for us, is that we're not focused on just threat categories with a known bad. We can open up sort of the whole gamut to isolate all that traffic to fully protect your organization. Similarly, with file downloads, you can set policies against different file types. You can even set and post unique file types or extensions that maybe are unique to your organization, and then apply the appropriate policies for those file types. Moving on down, SSL decryption exemptions. It's important to mention this, particularly in the context of scenario 2, where that user is navigating through banking websites. So those type of sites where there's personal or sensitive data involved, you can absolutely add that as a decryption exemption or a bypass. So effectively, we're still going to protect the user from malicious content, but we're just not going to crack open that encrypted session and see the information within. And those are all available within exemptions here. Similarly, with policy exceptions, if there is some sort of unique scenario or requirement where a user needs access to specific domains or categories, or maybe need to ratchet up the restrictions based on their location, you can do all that here within policy exceptions. The great thing about many of these, particularly for domains, if you have third-party feeds, you can easily just upload a file or some sort of document that references all of your domains that you perhaps want to whitelist or blacklist that maybe are fall outside of the categories that are contained within the platform itself. And then lastly, just to sort of wrap this up, I want to touch a little bit on bandwidth limits, which of course will be applicable to scenario 2 and of course all those use cases, but specifically use case number 3, where that user's in a degraded environment. So you can set bandwidth quota and apply that to users or groups. And then you can get granular and specify, bandwidth limitations for streaming media. So for instance, YouTube, you can set a resolution limit for an active video, so an active tab, and then ratchet up the restrictions for, let's say, a YouTube video that's playing in an inactive tab to further conserve and reduce bandwidth congestion. And of course, you can apply that to a variety of other streaming media sites. Now, I briefly did a couple demonstrations involving DLP and CASB. You'll notice all of these workbenches are also under this single pane of glass. And just to real quick call out a couple things here with DLP, we provide a variety of predefined libraries that really cover the entire regulatory compliance landscape. You'll notice we have a variety of regions across the globe that you can quickly tailor your searches for, and then you can leverage any of these predefined dictionaries containing keywords, regexes, and of course you can create your own custom repositories and then apply those towards policies. And then lastly, before I wrap up, CASB briefly touched on this, but this is going to enable you to get visibility into shadow IT, get an understanding of all the applications running in your environment, and then ultimately take control of those applications by creating variety of policies and profiles, and even custom, very granular rules to further control the type of activity that's occurring. So you'll notice here, I have the ability to prevent uploads, downloads, and even ratchet up further restrictions to prevent editing, creating, searching, deleting, etc. So with that, let me just recap what I've covered here today. So again, the focus was on scenario 2, across use cases 1, 2, and 3. Along the way, I've highlighted a variety of capabilities that are used to not only meet the requirements in scenario 2 in those use cases, but exceed them, provide further security, extending that protection no matter where that user is operating. And the bottom line here is that through isolation, we absolutely check that zero trust, that box associated with zero trust. So just to summarize our presentation today, isolation is a key architectural strategy. This has been publicly acknowledged and published by CISA, citing the DoD as a prime example of the success that's afforded, and of course, the security that's afforded to the DoD through isolation. I've shown you today that Menlo is that single platform that provides that protection against all web and email-borne attacks. And that's important considering that 90% of attacks originate from those channels. We've proven that our platform is extremely scalable and top-notch in terms of security efficacy, and of course, absolutely checks that zero trust box. We're proving that every day within the DoD with 3 million users deployed. And lastly, we would love the opportunity to talk to anyone on this call further about our capabilities, maybe have a more focused discussion and let you try out our technology. For those interested, please go ahead and record the contact information that you see here. Liz Alsop is one of our account managers. She's on this call. Darren Curtis is our federal vice president within Menlo. And then of course, myself, Mike Ryder, federal systems engineer with Menlo Security. I'll go ahead and leave that on the screen for a little bit longer, but with that, that concludes our presentation. I'll hand it back to the host, or if anyone from the Menlo team wants to chime in with some closing comments or thoughts, please feel free to do so. And thank you for your time today.
Thank you. We have just a few more minutes left. I see a question from Gary W. Is that Gary Washington? I don't know. But anyways, he said, what does it take to implement email security within O365? If you would like to answer that one, we still have some time left.
Sure. Yeah, I actually have it set up in my lab environment. It's actually pretty straightforward. Email isolation doesn't require, modification of MX records. It's literally a matter of going into your email flow and setting up routes to send email through our isolation platform, both inbound and outbound. And that enables us to, transform and execute those documents, those files, as well as those URLs. So it's a pretty seamless process in order to implement that.
Great, thank you. Joe Klein with MITRE, he just wrote in as well. Does your product allow the browser to terminate to your server via IPv6 only? And does your server connect to IPv6 and legacy IPv4 web servers? And his question is in the chat. It's a little lengthy, so if you want to take a moment to read that and then respond.
Okay, so based on the question, I might need a lifeline from Ray or Stuart or Nick on that one if you happen to know the answer there.
Yeah, thanks for the question, Joe. We get this question quite a bit, and we do have support for IPv6 in the platform. It's something that DISA has been adamant requesting. They do have IPv6 endpoints out there, and they're deploying more in the future. So we do have a plan around IPv6, and we do support it today.
And the second part of his question is, when should customers expect the service to be supported? Is this something that'll happen this year or next year?
Well, there's not a whole lot of websites that only have IPv6. So there's really two sides of the platform. There's the side towards the website, and then there's the side towards the client endpoint. I think you'll see us roll out the side towards the client endpoint probably later this year. As far as the platform reaching out to websites, we don't We haven't seen at least IPv6 only websites, so we're not sure if that's a hard requirement or the time frame around that.
Okay, good questions. If anyone has any other questions, we have 3 minutes left, but otherwise, Liz, did you want to say anything to close us out before we move on?
No, I just want to say thank you to the ATARC team, yourself, and all the attendees, of course. We really appreciate your time, and we're excited to share our platform with you. And as Mike mentioned, please don't hesitate to reach out to us. I believe you could get our contact information on this slide or from Kirsten if you have any difficulty getting that. But please don't hesitate to reach out, and thank you all so much.
Yep, happy to make that connection. All right, well, thank you guys. I'm going to stop recording now, and then we'll move on to HashiCorp.